Hey guys, welcome back to the channel. This is Omega Manufacturing. Today we have a super interesting project. It's going to be something to hold your balls, your golf ball. Come check it out.
All right, so check it out. Here's where we got the idea from, just here on Maker World. We have this design with the carabiner on it. Uh, has the text. Here's the average size of a golf ball, about 1.68 inches in diameter. We're going to be using that for our design. Uh, we just made a quick sphere here to reference. And then starting with the base of the design, we're going to create the overall sketch features like the spheres required, and then we'll attach them. So um, about an inch in diameter for the inside of our carabiner, creating an ellipse here. The outside diameter is going to be 1.5 inches. And then here where the golf balls are going to be, the golf ball is 1.68 inches in diameter, so adding about 200 thousandths of an inch for our wall thickness. That'll give us about 200 thou wall thickness, or 100 thou rather, sorry. And then here connecting the lines, so the structure. Pretty much just freehanding it to make a design that looks good, suits the intended purpose. Just the cutout here for the inside of the carabiner, trimming all the lines as required, and then we're going to work on the hinge design. So we want this to clasp. So here I'm making an ellipse or a circle rather, on the outside. That way when this is done and finished, that circle will come out in like a C shape and will be easy to grab, as well as maneuver into loops or hooks. So just making all these circles tangent to our straight lines. A lot of these dimensions are just, they're eyeballed. When you're freehanding something like this, it's tough to get exact. And then here we have the spacing for the 3D printer. So whatever your 3D printer, whatever its accuracy is, mine is not very accurate, so 20 thou is about right for us. So that's what I offset these lines to. So there's going to be a 20 thou gap, which my printer will actually not make a perfect 20 thou gap, but we'll get a new one eventually. So here, just trying to make, a latching mechanism. Messing around with the dimensions, uh, when you're freehanding it doesn't have to be exact, just close enough. And then we might iterate this design if it doesn't work out quite as what we wanted. Trimming everything up, giving ourselves a radius. Sharp points aren't conducive to the 3D printer. Radius to suit, they don't have to be exact. If we were making this for, direct manufacturing, yeah, like not an additive manufacturing machine, but maybe a milling machine or, you know, what have you, we might suit the radii to a cutting tool, but in this case, we're just adding layers on a print. So, and then over here, we're just going to add reliefs on the other side of this carabiner so that the carabiner can actually move back and forth. Just patterning these up. Again, dimensions aren't specific, just trial and error. And then extrude this through about 1/4 of an inch. Here my sphere got in the way. That sphere is just there for reference on the design. Looking at that latch mechanism, looks like it's going to be okay. Might change that in the future, like I was saying. And then freeballing where the golf balls are going to sit. Extruding that up, I extruded it up about the diameter of the golf ball, and then I offset it back to suit. And we can move that around. So the distance that you extrude that up will actually decide on how well it holds the golf ball. I'll show you that in just a second here as we subtract the actual golf ball. See, so as you can see, the further down that we pull that top face, the less it's going to hold on the golf ball. So just guessing, looks about good there. Maybe a little bit lower, so it's not holding the golf ball as much. Then if you print this and you don't like it, you can always, offset that down a bit more. So looking good. And then the bottom side of the golf ball, we don't need that. In fact, it's not, the printer isn't exact, so that we need a little bit of relief there. So just extruding that out so that it's just holding on the top side of the golf ball. And then I forgot my cutouts on the back side of the golf ball. We want these cutouts to be extruded out. That way you can grab the golf ball to pull it in and out. And then here, just trying to be a little bit more material efficient, just adding a relief cut. This design could be way more efficient. There are better designs out there, like the one I showed you at the beginning, the reference design, but I'm not too concerned, and I actually think this design's better. So it can hold your many more tees. Yeah, and it's just nicer overall. So again, just guessing on the dimensions roughly. I mean, T size, like the actual post of a T, the diameter varies. So we picked a good middle ground. It's going to be about 200 thou in diameter. And I didn't like that design. I wanted them to be offset from one another. And then Fusion decided to not let me due to constraints, so I just deleted it and started again. This design will be available on Thingiverse, Printables, and MakerWorld for free if you'd like to print it yourself. You can also buy them on my website. Just finding a good text here. I actually don't really like this text. I think we'll change it in the future, but we'll see how it comes out. Just something more bold would be more desirable. Then adding a radius to everything. Again, additive manufacturing machines don't like tight corners. A radius kind of just helps everything come out better, so you don't have to deburr anything. And now just whitening the letters makes them pop a lot more. One day I'll have a multicolor printer and I won't have to do this anymore. Nice. Few coats, it'll look great. And here's the final product. Please consider subscribing if you enjoyed today's video, and I'll catch you next time.